Okay, so this question is related to Wind's displacement law from thermal properties of matter, which says that lambda m into T is equals to constant. Okay, and this constant value is B is equals to 2.9 into 10 to the power minus 3. This is the value, meter Kelvin unit. Now in SI system, obviously. Now what is the question is the surface temperature of a hot body is this much, find the wavelength. So whenever you are asking about the wavelength, then always go with Wind's displacement law, because it says that lambda m into T, the multiplication of the wavelength and the temperature is constant, right? But here you have to note that the temperature unit I am using Kelvin. So, and it is not the change of temperature, it is exactly the temperature. So temperature should be in Kelvin unit, right? In Kelvin unit. So the as per the question, the temperature is given 1227, right? So the degree centigrade. So you, if you want to find out in Kelvin, then you have to add it with 273, then you will get 1500 Kelvin. Now find the wavelength of the radiates maximum energy. So basically lambda m you will get is equals to B by T. B is the Wind's constant. B is the value, you know, V is 2.9 into 10 to the power minus 3 divided by T means 1500. Now 2.9 into 10 to the power minus 3 divided by, you can write 1.5 into 10 to the power 3. Now this 2 can be cancelled, means nearly about 2, right? 15 times 2 is 30, around 2.9. So basically you can put it 2 into 10 to the power minus 6, because it will go at the numerator. 10 to the power minus 3 will be there. So 2 into 10 to the power minus 6 in meter unit. So what is the wavelength in another unit? Like lambda m is the answer, means you can also leave it like this, 10 to the power minus 6 meter. But because we know that 10 to the power minus 6 is simply micrometer, so 2 micrometer is the wavelength of that radiating energy. Okay, so this is the this is all about the means question, that what is the wavelength of that radiating energy. Means any hot body, if you leave that hot body, what will happen? It will radiate some amount of energy. Okay, so maybe in the form of infrared radiation, maybe in the form of light radiation, okay, visible range radiation, UV radiation maybe. So basically we are getting 2 micrometer, not that much amount, but still we will get infrared type of radiations from here. Okay, I hope it is clear to you. Thank you.